Hey there, it's Jason Gorman from Codemanship with the final video in our series on C# codecraft. In this video, we're going to be moving on to a more advanced codecraft topic, which is continuous inspection. As the name implies, continuous inspection means that we are continuously inspecting our code. Specifically, it's continuous code review. And as all things continuous in software development, the implication there is that it's automated, so it can be done quickly, cheaply, and many, many times a day. Just as with fast-running unit tests, the goal here is to essentially make sure that we're getting warnings or issues about code quality highlighted as early as possible when they're much cheaper and easier to fix, and to make sure that at any point in time our code is not just working with our unit tests but maintainable with our automated code reviews. This can reduce or remove the bottleneck of pull requests of having to do manual code reviews where maybe another person on your team needs to read the code and look for issues. So we tend to find that the more advanced teams have invested significantly in automating their code reviews so that they can essentially remove that bottleneck from the development process, and so that they can catch more issues earlier. The other problem with manual code reviews, apart from the fact that they take a long time, which makes them a bottleneck, is they tend to miss a lot of stuff like any kind of manual testing. Particularly if you're looking for a whole range of issues going through the code, to methodically go through the code line by line and apply, a dozen rules or 24 rules or 36 rules to every line of code with the best will in the world. Just reading the code isn't going to do it. So we tend to find that pair programming, for example, does definitely improve code quality if you've got the right pair, but it still misses a whole bunch of stuff because you're focusing on 1,001 things at the same time as well as code quality. So a lot of issues still tend to get through. So the teams that are producing the most maintainable code, the highest quality code, the fastest tend to be the ones who have invested in continuous inspection. So in this video, we're going to take a look at what continuous inspection is. I'm going to give you a few tips from an old hand about how you can apply this to your development. So first of all, continuous inspection requires us to be able to automatically analyze the code and apply rules to it. So you think of these rules as being just like they're business rules, but the business is code, if you like. In the same way that we might have a business rule that says every hotel room must have a television, we might have a business rule about our code that says no method should have more than 5 parameters. We'll have what's called a static analyzer. This is a tool that reads the code, for example, uses a parser, and creates a model of the code, usually referred to as an abstract syntax tree. There's a bit of computer science for you, that just represents the structure of the code. The assemblies, the classes, the methods, the parameters, and so on and so forth. And then we write rules that are applied to the structure. So rules that apply to methods, rules that apply to classes, and so on and so forth. The tool will then walk down this abstract syntax tree, looking for any rules that apply to any node in the tree that it's currently landing on. So where are all the rules that apply to this method, for example? And if that method breaks any of those rules, then it will record that. It will flag up some kind of record of the fact that there was code there that was potentially an issue. And typically what these tools will do is they will be programmed to sort of prioritize these issues. So some they will say, well, these are blockers, basically this should not be allowed in. Some will just be warnings, and so on and so forth. So we can configure our tool essentially to include the rules that we want to apply to our code, but also to set the policies as to what we do when that rule is broken. And do we warn them? For example, with an automated code review that's run as part of a build, it might say, okay, well, we're going to let this through, but we're going to, I don't know, send an email to the person who merged this code and just warn them and say, hey, you should take a look at this. Or the policy might be for this particular issue, that's a definite no-no. It's an open and shut case. We're going to fail the build, and you will have to fix that and try again. So we'll take a look at that in a minute. But first, let's take a look at the rules that are available out of the box with Rider. And you'll get very similar kind of functionality in Visual Studio. So what I'm going to do is I've got a little project here. I say little, it's about 1,000 lines of code. So it's not trivial, but it's not huge. And we've got a whole bunch of coding standards that need to apply to this code. And we have invested in codifying those coding standards into a continuous inspection platform. And we'll talk about what that means in a minute. And what I want to be able to do here, first of all, before we do anything, let's make sure that it works. So I'm going to build this. Let's build this solution. So it's looking, there's a couple of warnings there already. And then I'm going to run the tests. Let's run all the unit tests. Make sure this thing is green. So no point in worrying about code quality. Ah, very interesting. Very interesting. Let's rebuild that. So I had this a couple of times before where the tests were failing. I couldn't quite figure out why. Now they're all passing. So there's some kind of build order, maybe a dependency thing going on there. Bit of NuGet shenanigans or something like that. But it does appear to be working now, so that's good. So once we've taken care of the first order of business, does it work? Then we might say, okay, so imagine this is happening in a build, for example. We might then say, okay, let's review this code. Now, here's a natty little tool. You get something very, very similar for code analysis in Visual Studio. So don't feel left out if you're using Visual Studio. And as we'll see, it could well be using many of the same code analyzers. We'll take a look at that in a minute. But I'm going to ask it to inspect all of this code. So the whole solution, it's going to inspect all of the C#, and it's got built-in functionality to inspect other kinds of source files as well if they come up. Let's fire that off. Now look how fast it does this. It's done it already. Now, what happened there was the rider and the compiler, the Roslyn compiler, were actually inspecting that code in the background. We're going to talk about that in a while. So it's already got an inspection already run as part of that build. So we can dip into it. It's been done very fast. Now, this is a very comprehensive code review. Let's take a look. All the issues it's found. So we've got a bunch of, for example, some in-used imports. Let's take a look at these in-used imports there. So we've got some unused imports there, and they should go. And it's flagged up a whole bunch of issues like that. It's done it very, very quick. Now, imagine you were doing that code review by you asking your colleague to read the code, and she's got to go through all the code that you've changed or added and look for a whole list of issues. We'll take a look at the list of issues that this tool is checking for in a minute. And now that it's done this, here's another thing that's built into the Roslyn compiler. So this was an issue that was actually flagged up by the code analyzers that ship with the C# Roslyn compiler. And optionally, as well as having code rules that can be applied to our code, they can also have automated fixes that are built in. So let's apply this refactoring automatically, and we're going to remove, well, we'll do it from the file, but as you see, it gives us the option to do it from the whole solution as well. So it can do a whole bunch of stuff automatically there. Saves a bunch of time. Let's save that and let's rerun our unit tests. Make sure that's still working. And we can redo our code analysis. So we did a code inspection. It took no time at all. We can do another one. Look at that, no time at all. And you can already see it's been updated. Those issues have disappeared because we fixed them. And there's a bunch more compiler warnings and all sorts of stuff that we might want to think about. This is probably some sample code here. We'll talk about this later. So there's a field that it's spotted that's not being used. Again, there's an automated fix that. We can encapsulate the field. We can make it public. But that's... okay, it's not got an automatic fix for that, but we can probably fix it quite easily. And it chunks through the code very, very fast, churns through it very quickly, and inspects the code for a whole range of issues, some of which are more severe than others, and it gives us a nice little report at the end, so we can then go through our code and fix the issues. And the idea is that we would run this kind of code analysis many, many times a day. I mean, I'm in the habit of doing, code analysis pretty much as I finish each new unit test. I think, well, let's just run the tool and see what it comes up with before we move on. So that's kind of that code inspection that happens on a green light, and that's a good habit to get into. And we can do that very comprehensively and very, very quickly because it's all automated. Now let's take a look at some of these rules. So if we take a look in the settings for this solution, I've got it already open there in the inspection settings for severity. So this is where we can switch rules on and off. For example, if we think, oh, that's not important, we'll get rid of that. And we can also decide what happens. So a warning is like, it will compile, it will build. An error is no, that will be a compile failure, basically. So we can determine what rules are included out of the box, as it were. And as you'll see, there's a whole bunch of them here, a whole bunch of rules there, none of which say this code will not compile, none of which say this code will not work. They're one level above that, if you like. So they're thinking, well, yeah, it compiles and it runs, but is it good code? And if we go back to our tree here, so there's all the compiler warnings. Here's a whole bunch of things about redundancies in code, for example, unused imports and stuff like that. And we've got a whole bunch of those redundancies. Potential code quality issues, so a whole bunch of stuff switched on here. Now there are hundreds and hundreds of rules, hundreds of them. And what we tend to find is that teams that apply all the rules out of the box, they're getting a lot of what we call sort of noise, code review noise. Stuff that they maybe don't necessarily think is important, or they don't even necessarily agree is a problem. So you do have to invest in customizing the profile that you're going to use, and you need to do that really as a team. You need to come to a consensus on what you think is good and what you think is bad, and what you think should happen. What should the policy be? Should this fail the build? Or should this be a warning, or just a suggestion, or whatever? And there's a whole bunch of stuff out of the box here, but you do need to, don't just switch it on willy-nilly. You do need to sit down and go, okay, what's our actual policy here? And come up with a profile that works for you. As we'll see, you might also find that there are rules that don't come out of the box with Rider or with the Roslyn compiler. And then you're going to have to invest more time and effort actually developing your own custom rules, potentially. And most teams that invest seriously in continuous inspection at least have some level of customization involved there, which is an interesting skill set that's required for that. So a whole bunch of rules there, rules about end unit tests and blah, 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 and spelling issues, code notifications, all sorts of stuff. And we can switch them on and off, and we can change the severity, the policy as to what to do when that rule is broken, and come up with our own team's customized code quality profile. So it's very powerful. But you will notice, as I've been working on this code, all these little squiggly lines here, this is the Roslyn compiler working in the background, analyzing the code. So it's not just these days telling us whether or not our code is syntactically well formed, whether or not it will compile, and that's useful enough. But computers are powerful enough these days, that it can go beyond that and actually run code analysis in the background. So as we're typing, these little suggestions and hints and errors and warnings are appearing in real time in front of our eyes. So we're getting feedback almost immediately as we're typing about the quality of our code. And that's becoming much more commonplace. So it's not just part of the Roslyn compiler, although that they've invested very heavily in that. So it's very powerful for C#. But we're seeing that we're getting this kind of feedback when we work in Java or JavaScript or Python, because the tools now are so powerful that they're able to go beyond just background compilation, and they're actually able to do that kind of code analysis and code quality checking in the background. So I wrote a piece for Visual Studio Journal many years ago now where I kind of predicted this, that computers were getting faster. And what spurred me on was the existence of these things. Let's go back to my unit test session there. If we can find the button there, where somewhere, where's the little button that we can configure? There we go. So auto start test. So the idea of continuous unit testing, background unit testing, or continuous testing is becoming more and more popular. So it's built into Rider. You've got NCrunch as well for Visual Studio. So there are all sorts of great tools available that will run your unit test in the background. And these were starting to appear when I wrote this article. And I thought, well, it's only a matter of time then as computers get more and more powerful that we go beyond just compiling the code in the background and then running the tests in the background, to actually doing code reviews in the background. And I remember I think the name of this article was called Ever Decreasing Cycles. Back in the old days, when we did this kind of thing in the 90s, we kind of had to run these overnight because computers were not that powerful. So we were running our unit tests, many times a day, but code analysis still took up, it's quite a lot of number crunching power that you need to do this. So at the time, we would do a code analysis overnight, but there's an element there of sort of closing the stable door after the horse has bolted, because that developer's already moved on, and they're often unwilling to go back. So their code ends up just full of to-dos, stuff that could have been fixed, but now they moved on. These days in 2020, we can actually do this kind of code analysis in the background in real time. But it does take some investment. It's not just something you switch on and off. You do need to invest in customizing your code analysis, customizing the rules, customizing the policies and the severities, so that you have a code analysis platform that is working for you. And in particular, a set of code rules that you and the team agree on. And that's why code reviews don't go away. There's still a need for a team to get together and review code, but this time the emphasis is not necessarily on actually enforcing the quality of the code. It's a bit like exploratory testing in agile software development. We've got a whole bunch of automated tests, but what about the tests we didn't think of? Same thing with continuous inspection and code reviews. We've got a whole bunch of automated code quality checks, but what about the quality problems that we didn't think of? So you still need to read your code on a regular basis. Ideally do this as a team, so mob programming is ideal for this. Get round the code and go through it and go, okay, well, do we think this code, for example, is a problem? What's a problem about it? And then you kind of have to iterate the design of your quality gates, as we'll see, so that it's not an out-of-the-box, one-time, big bang experience. You don't just do it, switch it on, off it goes. You kind of have to learn as you go. And as you go, that will stabilize to a larger extent. But it's an iterative process, getting this thing up and running. You don't just switch it on. So there you go. There's code analysis, continuous inspection in Rider. You can do something very similar in Visual Studio. It's a very mature platform for that as well. And if you're working in, for example, VS Code, the Roslyn compiler can do this from the command line. It will still be doing it in real time as you're typing in C#. So you're still getting a lot of the benefits of that. And most code analysis tools can be run at the command line as well. So you don't have to feel left out. But obviously, it's very, very nicely integrated in a very friendly visual way in Rider and Visual Studio. Okay, so that's one tool set that's available. You do not have to use the Roslyn compiler code analyzers. You do not have to use Rider or Visual Studio. There are other tools available, often with other emphases. So we're just going to take a look at some of these tools. So first of all, I just want to draw your attention to a cool tool called Endepend. So Endepend has been around for quite some time now, I think more than 15 years. And it does a very similar thing to what the Roslyn code analyzers are doing. But in my opinion, it has one of the most mature code models that you could use, because as well as all the information about the structure of the code, it adds a kind of layer of information about the relationships in the code, and particularly the dependencies, hence the name Endepend. So if you're an architect, for example, and you've got a whole bunch of rules about separation of concerns and dependencies and encapsulation and blah, 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 and rules that say that, and nothing in that project should depend on anything in that project and all that kind of stuff, that's very easy to do in Endepend. That's essentially what it was originally built for, I think. But it's got all those other layers as well. So it does measure code complexity and number of parameters and number of methods and sizes of classes and all that kind of stuff. Unlike the Roslyn compiler, it's not working directly on the source code. It's working on the bytecode. It's working on the intermediate language stuff after your code is compiled. And that has one big advantage over something that is kind of a native C# code analyzer, and that is it will work with any programming language that compiles to .NET. So whether it's Iron Python or F# or even VB.NET, although frankly, if you're working in VB.NET, I doubt you care very much about code quality, he said, to our VB.NET audience out there. Does anybody still work in VB.NET? I don't know. I haven't come across it for a long time. Anyway, so it has that advantage that it works on assemblies rather than source code. So anything that compiles down to intermediate language, down to .NET assemblies, you can use this on. It's nice and visual. It's got a very, very feature-rich interface, as you can probably see from the previews here. I mean, it takes a bit of getting used to. There's a lot in there, a lot under the hood, as you like. It comes with a whole bunch of useful out-of-the-box rules, but as I said, with the Roslyn compiler and with Rider and Visual Studio, you do need to invest in making sure that you're using the rules that you as a team find valuable and useful. And that may involve you writing your own custom rules. And in NDepend, there's two very simple ways of doing that. One way is it comes with its own code query language. So it builds a model of the code, and then it has its own code query language. And you can also use LINQ to query the code model as well. So you can do some quite powerful and sophisticated things with it. It can work as a desktop tool. You can run it at the command line, so you can also run it as part of a build. And we're going to see another tool that kind of focuses on code analysis and builds in a minute. So it's very versatile. It's very good value for money. It's not free. It's not open source or anything like that. But then, technically neither is Rider. But it is very, very full-featured. It's been around for a long time now. Now, another tool that also uses intermediate language stuff, that's been around for a very long time too for .NET, is called FXCop. And you might have come across this. FXCop was like the precursor to the Roslyn compilers, if you like. And similar kind of thing to NDepend there, except that it doesn't really have, I think maybe there probably is a GUI you can use with it, but I've not really played with that. But generally people run it at the command line, and you have a whole bunch of out-of-the-box rules that you can apply, and you can customize. Again, you can customize what rules to apply and what the policy is. Is that a failure? Do we say that's an error, or do we just give a warning, or et cetera, et cetera? And you can create a quality gate. Typically, again, these were incorporated into builds. So back in the day, we would run these overnight. It's kind of been superseded by the Roslyn analyzers. And with good reason. They're much more powerful and much more elegant, I think, than FXCop, as we'll see in a minute. But there's still a lot of people out there who are using FXCop, and there is some backwards compatibility. There are adapters that you can use essentially to use your FXCop analyzers with the Roslyn compiler. So you don't have to throw all that away if you've invested a lot in FXCop. Now, here's an interesting fact. The project that I was using as my example in Rider here, in actual fact, what is this project? It is a set of FXCop code rules. So some custom code rules. So these were originally designed as a set of rules that I would then run when I'm like giving people what was called the Codecraft driving test. So they do a little project and we check a whole bunch of stuff like, are the tests passing and blah, blah, blah. But one of the other things we check automatically is whether or not they're satisfying certain code quality rules. So what I did here is I put together a few example rules, and we can take a look at our rules here. So these are FXCop rules. These are the tests, the unit tests for the rules. So remember, this code analysis code is code. And therefore, it also needs to be maintainable, and it also needs to work. So you need unit tests for it. So there's a bunch of unit tests for my rules. Let's see if we can find the rules, get a little feel for how they actually work. And somewhere in here, here's a rule about the number of methods in a class. And it's what we're saying here is that this rule applies to the code object here. And we're saying the code object it applies to is type. So there's no such thing really as classes in intermediate language. There are types, and they can be interfaces or classes or that kind of thing. So every time we hit a type, as we walk down the abstract syntax tree of our .NET assembly, we apply this rule. How many methods does this type have? If it has more than 6, then we say, well, that's a broken rule. So we're building a list of rules that have been broken. And we supply some information. For example, this broken rule, well, what is the rule that was broken? Number 1, that's this rule, this class. And also, what is the source of that rule? In other words, what object triggered this broken rule? So there's an example of a very simple customized rule. And you do a similar kind of thing with all of these tools, basically. The Roslyn analyzers, you can write your own code rules and your own automated fixes as well, which is one big advantage of Roslyn analyzers. You can do it for FXCOP, you can do it for NDepend relatively straightforwardly as well. And it is worth, you're going to find out of the box that you don't get everything you need from any of these tools. It's never happened to any team I've worked with once. There's always been some gaps, and for those gaps, you might need to roll up your sleeves and do something like this to actually write custom rules. Relatively straightforward to do. So that's FXCOP. It's still around, nowhere near as much used as it used to be, and it certainly has its quirks, but it was a pretty useful tool. And the final tool we're going to look at now, well, I'm going to go back to Rider, and I'm going to demonstrate this. So there are a lot of teams now who have multiple sort of streams of development, often working in multiple programming languages on different tech stacks. So there'll be some folk working in JavaScript, there'll be some folk working in C#, there'll be some folk working in F# or something like that, particularly if your architecture is very broken up into, for example, microservices. And you may find that it becomes very difficult to kind of keep a handle on overall code quality of that whole sort of what's the word we're looking for? That portfolio of different code bases that you're looking after, particularly if you're, for example, a technical design authority or an architect. So I'm going to finally show you a tool that is kind of usually used as built into builds, but there's no reason why you have to use it that way necessarily, that presents all of this information for all of your different projects for multiple different languages on a single web page, essentially. So you're getting a heads up on code quality that's done in a kind of standardized way, but then can be customized for all of those different languages and for all of those different teams. But it allows us all to get not just the benefits of doing continuous inspection, but also to get that bird's eye view of how it's going in terms of code quality. So I'm going to demonstrate this tool. We'll do it from the terminal. The name of the tool is Sonarcube. Now, Sonarcube is like a platform for continuous inspection. I think that's pretty much what they would call it. And it has all sorts of plugins for handling different languages. So I'm going to use a Sonar scanner, it's called, that's going to scan this project. It's going to scan this code, analyze the code, and then it's going to squirt that information to a shared database, which we can access through a website wherever we happen to be. So first of all, what we need to do, we've checked that the tests are passing, so that's good. So let's start our Sonar scanner. Okay. I think it's begin, actually. Sonar scanner begin. And then we need to give this a name. What is the name of this project as it's going to show up on their website? So it's codemanship.codecraft. So each code base will get its own kind of like little place to put these results. Okay, so that's going to sort of set things up. Off it goes. And then what we're going to do is we're going to build this solution. So I think it's quite possible that, as you can see, it says it's installing the Roslyn analyzer. So it's using many of the same tools that Rider's using as well. And then finally, I think it's end. It's going to crunch through that, it's going to build the report and send that information to the shared database that we'll be able to access from a website. Okay, now it's going to, as part of the results there, it's just showing you where to go on this website. So this is running on my desktop here, but it's running with a sort of proprietary database because this is the sort of the free version, if you like. You're very welcome to give me a fully functional version if anybody from Sonarcube is listening. But you can also get a commercial version, like a production quality version of this, where you can use something like SQL Server instead, so it scales up beautifully. Okay, let's go to the website there. Okay, lovely. And it's just done our analysis there. I don't think that is the result that we were looking for. Let's try again. I don't think it's done it. I don't think that is our result. Let's try again, shall we? It doesn't seem to have found the issues. Let's go back to our main dashboard here. So we have this dashboard of, oh, there it is there. So we have this dashboard here of results for a whole bunch of things. So there's a Java project, for example. There's another Java project. We've probably got some JavaScripts further down. There we go. Some JavaScript, some more C#, etc., etc. And this is the one that we just analyzed. Let's take a look inside. I do not know. New code. That's what's happening here. Very clever, you see. The result I'm getting here is not for all of the code. It's actually just for code that has changed. And what it's saying here, and this is very, very useful, and FXCOP can do this as well. It's just telling us what's different about the code since the last time it ran an analysis. And this can be very useful, for example, for just isolating problems with a particular check-in. Or also, if you're working on legacy code, the code that you know has lots of problems, and you're like aware, well, yeah, we know there are thousands of issues, but what's new? And this is a good pattern when it comes to code reviews, which is to focus on what's changed. So if your code is not great, you can kind of set a line there, draw a line in the sand, or set a bar there and say, okay, at the very least, it should get no worse. And so this is a very, very useful feature because it's highlighting issues with new code. We look at the overall code. There we go. We kind of get a final report. These are I find quite useful just as an overview. Reliability, well, it thinks it's found 3 bugs. Let's take a look. Use the return value of method. Why is this an issue? So let's take a look in this code. Okay. Interesting. Use return value of method to upper. Why is this an issue? So it can give you a bit of feedback there. When a call to a function doesn't have any side effects, what is the point of making the call if the results are ignored? Interesting. Okay, so it looks like a little bit of redundancy there, not necessarily a bug. So it can also highlight things like security issues and also like embedded URLs or embedded passwords. So there's a bunch of stuff in there that it can look for. Code smells is interesting. So here's a whole list of stuff, many of which we might be aware of. But there, for example, those unused imports, and it takes us straight to the code and tells us where the problem is. So similar kind of deal to what we were doing in Rider and also what we would do in Independent. Same kind of pattern, but this time it's all kind of centralized. And these typically are part of your build pipeline. So as a sort of a last line of defense, you're setting up what are called quality gates for your builds, so that these sort of take the place, if you like, of those pull requests. And only code that's good enough gets through that quality gate. And if it's not good enough, it will fail the build, and we can spit it out and say, okay, that's a failure. So let's take a look at how we can configure these projects. So for this project, we can configure rules. So there's a list of a whole bunch of rules that are available for C#, 385 of them, rather a lot. Okay, and we can sort of see what those rules are about and get a feel for how they work. And we can construct quality profiles. So here's the default quality profile for C#, which has 249 of the rules switched on. But we can change that. We can create our own C# quality profile here. Let's call this the codemanship way, because I don't necessarily agree with our friends from Microsoft or from Sonarcube about code quality generally. So let's create our own version now. And at the moment, we've got no rules switched on. So let's activate some rules. Take a look at an example. Let's just go for code smells. Very interested in looking for code smells, so a whole bunch of code smells there. Switch statement should not be nested, or I totally agree with that. So we can activate that rule, very similar to what we were doing in Rider there. And we can say, well, what kind of bug is this. If it's a blocker, we're saying fail the build, essentially. Fail the build. Critical means someone needs to look at this. So it might be, for example, with critical, that we don't necessarily fail the build, but we flag it up straight away with the person that's checked in those changes. All the way down similarly to, you know, well, this is just for informational purposes, or you might want to take a look at this, etc., etc. Okay, and we can activate that rule, set it up the way we want it set up. And once we've built our quality profile, our list of rules, and again, we can also write customized rules, including customized Roslyn analyzers. We can then set up what are called quality gates. So using our codemanship way rule there, we can specify what happens when certain thresholds are breached or where certain conditions are met. For example, I say there should be no critical issues there. So here's our quality gate. We're saying basically, this is what gets through. This is what gets through, or rather is what not gets through, sorry. So project with, etc., etc., etc. And we can add our conditions to that. So to new code or to overall code. For new code, for example, okay, let's talk about code coverage of tests. If we're we can bring in also, and we can do this in NDepend too, we can bring in code coverage files from code coverage reports, and that will be then sort of cross-referenced against the code. And we're saying the add condition greater than 95%. Okay, let's add that condition there. So we can add a bunch of conditions to specify essentially what gets through in a build and what doesn't get through. And this then gets incorporated into our delivery pipeline before we're in a position to actually merge the code usually, but also afterwards as well, just as a final last line of defense. This will break the build, so we can incorporate it into our build pipeline there. So that's the basic idea of continuous inspection. It's automated code reviews that we can run over and over and over again, ideally many times a day, but at the very least, when people are actually checking their code in, we check their code automatically to make sure that it's up to standard. And if it's not, then we will have policies about what we do as a team when that rule is broken or that condition is broken. So, and that takes the place of code reviews, takes the place of pull requests as a way of testing code quality, but it doesn't remove the need for the team to remove the code, to review the code, because we still need to come to a consensus as a team on what we think should make it through and what we think shouldn't. So we need to be also continuously reviewing our inspections and continuously reviewing our quality gates and our rules on an ongoing basis to make sure that they are evolving to be something that we find genuinely useful. Because the least useful thing, the least helpful thing for a team is to have something like this, but everybody just ignores the results because either there's too many rules, or they don't agree with the rules, or they already know that that's a problem, and etc., etc. So you do need to reach a consensus as a team. You do need to invest in this. It doesn't come for nothing. You need to spend some time on this. If you're writing customized rules, then there's a new skill set involved in doing that as well. So there's a bit of a learning curve. But it is worth it. If you can get it up and running and get it working for you, it really is genuinely worth it. The highest quality code that I've ever seen invariably comes from teams that have invested in continuous inspection. It's not beginner stuff. Takes a bit of working up to. You've got to invest in this, invest in skills, invest in tools, invest in time. And I appreciate there are a lot of teams who are not willing to make that investment. But it really, really pays for itself many, many times over. So there you go. That's continuous inspection. That ends this series on Codecraft with a bit of advanced Codecraft there for more advanced developers and teams. I hope this series have been of some use. If you haven't watched the rest of this video and the rest of the videos in this series, I highly encourage you, of course, to go back and look at them. But also there are going to be many more videos coming to this channel that will be of interest to C# developers and software developers generally. So hit the subscribe button or ring the bell for notifications if you want to be kept up to date. And there you go. That's Codecraft for C#.